Okay, so I put out that first version of C scripting, and I got some good feedback. Thanks to Martin's on the Handmade Network Discord, as often is the case. He pointed out something I could do to make a huge upgrade to the way the Windows one is working that I want to explore today. So we're going to do a little more C script developing. I'm also testing out an old Windows laptop. This is an old Windows laptop. It's the one I developed 4Coder on, in fact, and it's been in a closet for a while. And I've been getting ready to switch over my main machine to being Linux. So I wanted to figure out how I would keep around some kind of Windows testing device, and so I set this up to do that. And so today I'm also operating with the dual purpose of testing out this environment to see if it's good enough. It doesn't need to be a development space where I really do serious stuff, except to debug the Windows versions of my programs in the future, right? So it's got 4Coder, it's got C scripting set up already, and it's building the example. So we could also go and make sure it's running the example, right? Okay, so it's running the example. Everything's good to go. Now the question is, where do I want to get started? I guess I need to go... I'm going to compare an example here. And this has to do with how we define symbol sets. This part, the boilerplate that you copy paste to define a symbol set. And in particular, the idea is this. I have it set up right now where you have to type out this section name. It has to start with .sy dot for the Linux toolchain to work. But that means on Windows, since each section name needs to be unique and I can only have 8 characters on a Windows executable file, that this character, the part of the name you actually have control over is only 4 bytes. You get 4 ASCII characters, basically. And that sucks. So, fixing that would be great. And the thing Martin's pointed out is that on the PE-COF toolchain, right? So we have two main toolchains to look at. We have the ELF toolchain, which is running on Linux, and the PE-COF toolchain, which is running on Windows. And in the PE-COF toolchain, it's true you only get 8 characters in an executable, but in an object file you can have any number of them, and you can put a $sign in there. And that sort of serves a similar purpose to having the linker script on Linux, actually. What that says is, let's pull out an example here. Let's just look at, say we have an object file, and in that object file, it contains something like, let's say it like this. It contains .sci, and then let's say it contained $foo, $bar, whatever, right? What the system does is when it has an object file that looks like this, and it takes, the linker is the thing that takes in a set of object files and gives you an executable, right? So when we get an executable file out of that process from some set of object files, what it does is it takes all of the sections that have these $signs and it turns them into a single section that doesn't have that $sign. Right, and it does that across all the object files at once. So this foo section and this bar section from the same object file would get stuck together. But if you had another object file going in and it had a baz section or whatever, then that would also get stuck into the same final executable section. It sticks all the sections with the same prefix before the $sign together into one section. And furthermore, within that section, it's alphabetically sorting these. So this would be the concatenation of, you know, bar, baz, food in that order, alphabetically sorted by those dollar signs. So the dollar signs themselves disappear and the name shrinks down to .sy, but the dollar signs tell us how to sort the section. And the reason we want to be able to sort the section for symbol sets is because what we can do with that is we can say, all right, everybody's going to make these separate symbol sets, and we want to have them concatenated together into a single. I should have added this too. If I have a, let me back up and add this piece of information. If I have a bar in both, it puts the bars together from both object files, right? That's important to specify in how this works. So not only does it sort them alphabetically, it also, because it's sorting them alphabetically, I suppose, putting them, concatenating the equal named sections, right, from the object files. So that means we have a way to build all of our C scripting, sections down into a single section, just like we do on Linux using this, right? So no longer do I have to have a separate whole section in the executable at the end. I can get it down to one section and therefore truncate the amount of pages that have to get allocated for data sections. As a, cause that's a part of how this has to work, is you have an overhead of it's allocating a new data section in your executable virtual memory space. If that was once per symbol set, that's a bunch of times that it's, getting 4K, even if you only need 100 bytes. But now it's only going to do it once, no matter how many symbol sets you have. That's a big improvement. The other thing we could do with this, though, is to automate the discovery, right? So what I was doing before to discover sections in the PECOF toolchain was to read out, right? That's the self-imaging thing. I've been reading out the data sections from the executable while it's running. But that's not going to work anymore because I'm going to collapse them all down to one data section with this distinction between the object file data sections and the executable sections on the PECOF toolchain and this sorting mechanism that it has. So if I'm going to collapse them all into one data section, I need a new solution, and the new solution can also be provided by this $sign sorting thing. Because what we can do is say, all right, if you've got your sec_z here, right? You got the name of your whatever name you paste in here to set up your symbol set data section that gathers all the variables together into one contiguous block. That name is going to go, let's change the example now. So this would be like sec_z, right? And you're going to have like an A underscore, a Z underscore, and an M underscore. And A is going to have one element in it, and Z is going to have one element in it that come from a special object file that's like the main one. Other object files will just add the M one. So the M one's like the main or the middle. And so that's where all the symbols actually exist. The A and the Z give us sentinels that we can reference to locate the middles. That's the idea, right? So then what'll happen is all of these, well, this doesn't work. I have to do it like this, my bad. A, M, Z, because we still want them sorted alphabetically by that priority order, right? It's not that the, all the sentinels shouldn't go at the beginning and then all the middles. It should be the sentinel for this section, the middle for this section, and the end sentinel for this section, and then do that again for every section, right? That's the pattern that we want them to sort into. So then this would be, coming out looking like this. And so on and so on, right? Except it would sort them like this. Anyway, that's the plan, right? So then there's a variable in the AZ section to locate this. There's another variable in this AZ section to locate this. We can reference those variables because they have variable names, so we don't need to be able to find the sections at runtime anymore. We'll just use the linker toolchain trick that this toolchain has to do something similar to what we did with the linker scripts. It does still mean you have to allocate these sentinels, though. That is the one thing that isn't quite as tidy here, is you still have some zeros set aside just for the sentinels to exist. So that's the idea. Now the question is, what will the interface for the macros be? Because the idea is you copy paste this, right? And I have to keep this as the copy pasteable thing, right? That's a big part of how this works, is you embrace a little bit of heavy boilerplate because it's not a proper language feature. It's a hack together infusion of the macro system into something new, right? So the question I have right now, okay, so everything works, right? If I were to go look at example1.h, it sets up a script right here. Can this compiler still work if I put it like this? I don't think it's going to let that work, which is really unfortunate, because if that could work, then we could split up So what I was hoping it would do is do what it does at, do with strings in the C language, which is that if you put two C string literals together, it treats it as a concatenate, like a static concatenation of those string literals. And that way I could use the preprocessor to assemble section names, but it doesn't look like it's going to let that work. Symbol set define.h. You're referencing the section here. So I just want to do this without the abstraction layer just to make sure I'm seeing everything correctly. I'm doing this through a couple of layers. I want to just do a quick main.c. Can I get a main.c? Thank you. And what's the build? I guess I'm going to change this one for now. Okay. Good option. And then I want, basically I want to try to build a couple of tests here. So, I need to go and change some four-coder config. It's doing 4 wide tabs. I don't like that. Let me change gears for a second. Is there no config file? Is that what's happening? Load bindings, project config, default config. Let's see here. Okay, so I just do this. There we go. Got a little hello world started there. Can we get a global variable? I'm pretty sure that the answer is going to know already, but I just want to explore this a little more carefully how it worked. So pragma section, before we do the complicated thing, it's just like dot sci dot tmd, read write, and then you need symbol set dot age. Right, so I need to go to the symbol set base. Section read write. So it's like something like this, right? Like so if I do all that, I'm gonna throw in okay, so that's building and running in a way that makes sense. And if I type this in literally, it still builds just fine. The pragma is doing this without a problem. But if I do this, yeah, it doesn't recognize that. Which is unfortunate. And then if you did do this, what would it do? Right, it's just like, that's not supposed to be there. Okay, so that's just unfortunate because it's like it half works and then there's nothing we can do about the fact that it doesn't really work. So if you were gonna have it generate out like this, do I need it like this, or do I have to give each one of these a pragma now? Probably the worst case scenario, yeah. That's kind of unfortunate because it's going to make the boilerplate thicker. But I think it's worth it. Cool. Cool. So to explain what that does is, um, there's our beginning sentinel. We ignore it. It just sits there being 0 for us. There's our end sentinel. Again, we ignore it. It just sits there being 0 in a different location for us. But those positions gave us 1, 2, 3. Right? Inside of our section at the end. After that, it got built and linked the normal way, right? It's guaranteeing that order like we would want. And these then can be arbitrarily long. Like this could be command foobar A Z M A M M Z. So the restriction on length can be lifted, and the startup time self-imaging can be eliminated, all for the price of the boilerplate now has to have 4 copies of the section name instead of 1. Because we need 1 for each sentinel, 1 for the middle, and then also the one that isn't for the PE cough toolchain, but for the ELF toolchain. Right? And there's just very little that I could do to simplify it, because these have to be typed as single literal strings. Unless I started metaprogramming, like just generating the C code from something else, that part will have to be poorly abstracted, right? But that doesn't mean we can't wrap it so that it's only at the definition site where the boilerplate gets a little fatter. So basically what has to happen is we're going to rename these to like ELF section, and then cough A section, M section, Z section, like this. And then they'll have names like M and Z. But you'll still just, go, okay, rename this to my command foobar section, and there you go, right? The flow can be good if you still got a good text editor. It's just, that's what it's going to have to look like. And then if that's what the boilerplate starts looking like, then I should, well, let's delete the main and go back to build and say no more of this. We're just going to do this. And example1.h is currently on the old boilerplate, so let's redo that. Okay, so That should break it in such a way that we can pop in here. Try to fix it again. So this is no longer just section. This is cough A section, M section, and Z section, right? So these come from these now. None of this will exist anymore. And these are going to be like, where is the, let me see the base, or I could probably do it with this, right? Sec, read, right. But that's not going to work anymore because they use different section names now. You have to decide which section name to use. I'm going to need to wrap this thing in a per operating system switch. But first, let me grab this idea and say we also want, probably just want this too, right? Like probably what I need to do is just say this cough A section, symbol type. So this has got to be a glue of the symbol set define and cough A section. And this has got to be a glue cough Z section. So we still need a main like we did before, but now this looks a little bit more like the Linux version in a way. The symbols aren't in the right spot though, right? Or the first one isn't. The first one's actually off by one, which is going to be another issue to deal with. So that's fine. We can come in here. Let's come at this from the other angle now. Size section and init should be done. We actually just say you are not a part of the system anymore. Okay. And here we have a operating system switch for interpreting sci first and sci last. The difference now is that it's become this. Right? It used to be take the address of some pointer, or it was, no, this is, I'm editing the wrong one, my bad. Good thing I tried to talk that out. I was confusing myself. Linux. Okay, this one. This one becomes take the address. That makes actual sense. Okay. Okay, so whoa, not acceptable. That still exists as a thing? How did I ever do that? Okay, okay. Config fade out false, please. Ah, okay. So in order to do this properly, I should probably say something more like this, right? That'll probably work better. Where are we at? I suspect that this is just because I didn't actually finish setting this up at all. Yeah. Okay. So what we want is the name of the section, if, or no, the symbol set, right? Just this is on Windows sci-sec read write s ## underscore cough m section. And on Linux, it's elf section now. Right? So now we can declare members of the main section by just doing sdecal. There. Okay, so that's working. So I took out the runtime stuff, the cyanit thing, or not cyanit, the self image stuff. I took out self image, and I swapped out the boilerplate for this one that has the cough sections ordered like this. And then everything else worked after I hooked up the macros slightly differently, it looked like. So that's cool. That's really cool. That makes me wonder, are we still doing anything before main now? Is before main still... Before main. Here I define it. This is Mr. Fourth Base for LD Meta, but before main is out. Before main has actually been removed from the set of things you need to do C scripting. That's crazy to me just because of the fact that that's where it all started. Like, I was playing with that possibility and then thinking about the implications of the way that it uses data sections that got me to switch gears to using data sections. But it was all about trying to throw more declarative power into the global space of C. And it just sort of turns out that in the spirit of C, you get what you get out of the symbol set thing when you're doing data sections is no initialization cost outside of the memory copy to set up your program that you already were going to do sooner or later anyway. Most of the time, it feels like. And the other thing is you can no longer count on it to just do things automatically, but you can organize any group of things or phases of things you want to do automatically and gather them up from disparate declarations in whatever order makes sense. And that's just right. It just ends up as a data table at the end. It just seems very like a C way to do it, is to have it gather up those declarations into a flat array and then say, if you want this to do stuff with it. And then most of the things you want to do to make it feel automatic are still very available from there. And so before main is just not actually what you want. That was the CRT's C scripting. But now I've just got my own. So what's next? I've got the Windows 1 working. I guess let's update the README. I think I'm just gonna publish this. We're gonna just go straight to getting this out so that not too many people invest in version 1.0 and we can get to version 1.1. Should I update the date or I'll just write it like this. July 3rd, 2026. Okay. Now, what I'm going to change is locating data sections, Linux version linker script, Windows version. Extended section names. with the same base name but different extensions, then they are concatenated together and sorted alphabetically by their extensions. So we can place a special sentinel variable at the beginning and end of each section, symbol set section, and use those variables to locate the symbol set. This trick looks like this. This is how the trick looks. We have to set aside enough memory for 2 dummy nulls for extra 2 copies of our type to set up these sentinels that we don't really want. But it's the best solution without hacking. Best reliable solution so far. Okay. That's also going to change the part where I'm looking at the boilerplate. I think that's everything. Okay, let's make some changes. I think that'll do it. Now let's get this out there before too many people start using version 1.0 and not knowing that it's not good anymore. That something better already has come online. Okay, I think that'll do it for me on this Unscripted. I'll see y'all maybe next time.